Alright, so beyond the simple problems that you have in the beginning, there are other problems that get a little bit more complicated, so we're going to do this one together. So, a 15-kilogram bowling ball is hanging on a rope 2 meters off the ground. I pull it up so it's 3 meters away from the ground. So something changed. How much more potential energy does it have now? So we're going to start off with our diagram. Alright, so first, it's me. Alright, we've got our bowling ball which starts here, and that's 2 meters off the ground. And then I lift it up, so that now, and I'll draw like a little bowling ball up here, it's 3 meters. And so what's really, really important here is to find the change, okay? We know it started from 2, and we pulled it up so it was 3. So the change here is going to be 1 meter. It only changes, goes up 1 meter from 2 to 3. Alright, so now let's find our known values. So a 15-kilogram bowling ball, that's easy. So this is from mass, 15 kilograms. And then we've got, it's hanging on a rope, 2 meters off the ground, I pull it up, so it's 3 meters away from the ground. How much more potential energy? So we know we're solving for potential energy. Doesn't say what planet we're on, so we're going to assume it's Earth, so that's about 10 meters per second squared, acceleration due to gravity. And then change in height, so this is where this really comes in. If you draw your diagram properly, you'll see it goes up 1 meter, so the change was actually 1 meter. Alright, so now we're going to plug it into our equation. So we've got PE equals mgh. Potential energy is mass times gravity times height. So let's see, we're looking for potential energy, so we don't have that known value up here. And then we've got our mass, which is 15 grams. Okay, and we're going to put these in parentheses again just to separate them out so we don't get confused with all the numbers. Gravity is about 10 meters per second squared. Let's see, 10 meters per second squared on Earth. And then change in height. So because we drew this diagram so well, we know that it's 1 meter. Alright, perfect. So now that we've got our values plugged in, we're going to solve for the answer. So we've got PE equals 15 kilograms times 10 meters per second squared times 1 meter. Alright, so we'll do them one at a time. So 15 times 10. So now we've got PE equals, so 15 times 10 is 150. Okay, and then we're still got 1 meter that we're multiplying that by. 150 times 1, easy. Alright, so I've got my potential energy equals 150. Alright, now we know that our answer for potential energy is in joules because we're talking about energy here, so we're going to write down final answer. So with units, potential energy equals 150 joules. And I'm just going to write J to abbreviate for joules. So we've got potential energy equals 150 joules. That's it.